This is Chapter 3, Section 4, Graphing Functions, Lesson 1, Video 1, Graphing Solutions given a domain. So the first example says to graph each function for the given domain. A is negative x plus 2y is equal to 6 for the domain negative 4, negative 2, 0, and 2, and B is f of x is equal to the absolute value of x for the domain negative 2, negative 1, 0, 1, and 2. I will be graphing both A and B on the same graph, but with different colors to distinguish between the two. The first thing that you need to do for A is to actually solve the given equation for y, so that's y equals. So if we take negative x plus 2y is equal to 6, add x to both sides, that gives you 2y is equal to x plus 6, divide by 2, and you'll get y is equal to 1/2 x plus 3. Once you have set this one equal to y, just so that it's easier for you solving wise, you can go ahead and begin by making a t-chart. The x values are the same as our domain, so negative 4, negative 2, 0, and 2. And then from here you can now plug in each of our x values into our equation in order to find the matching y. So again, our equation is 1/2 x plus 3. So 1/2 times negative 4 plus 3 is negative 2 plus 3, which is 1. If you plug in negative 2, that's 1/2 times negative 2 plus 1. That would be plus 3. This 1/2 times negative 2 is negative 1. Negative 1 plus 3 is 2. Plug in 0, you'll get 1/2 times 0 plus 3, which is 3. And then if you plug in 2, that's 1/2 times 2 plus 3, which is 1 plus 3, so 4. From here, I'm going to go ahead and graph this one in a blue. But I'm first going to set up my graph. And again, the first thing that you always want to do is to get your x and y axes. Drawn in and labeled. So we'll go 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. And I'll do this specific graph in blue. So our ordered pairs are negative 4, 1. So negative 4, 1. Negative 2, 2. 0, 3. And 2, 4. And you'll notice that I am not going to connect the dots because it's asking you to graph specifically to this domain. If it told you just to graph the equation, you would still make a t-chart and then connect the dots. But because it's only to the given domain, you do not want to connect the dots. So please leave the points discrete, not continuous. So for the next one, okay, now we have absolute value. So it's pre-set up, so all we have to do is start with the t-chart. And again, the x values are our domain. The function is the absolute value of x, and then we're going to get our y's. So the absolute value of negative 2 is 2, the absolute value of negative 1 is 1, the absolute value of 0 is 0, absolute value of 1 is 1, and the absolute value of positive 2 is positive 2. For this graph, I'm going to go ahead and graph it in green. And our ordered pairs are negative 2, 2. Got a nice little overlap on that one. Negative 1, 1. 0, 0. 1, 1. And 2, 2. You should notice that the first one, the one in blue, makes a nice line, while the second one made a V. Okay? So again, when you're doing these, you will start by solving it for y if it's not pre-solved up for y. Then you're going to start building a t-chart. Then you're going to fill in your t-chart and then graph the points. You try. Graph each function for the given domain. Negative 2x plus y is equal to 3. For the domain negative 5, negative 3, 1, and 4. And then f of x is equal to x squared plus 2 for the domain negative 3, negative 2, negative 1, 0, 1, and 3. The overall goal is to get an idea of what the shape would be of the function itself, but again, do not connect the points. Please make sure you show all your work, and that is the end of this video.